So I'm Dr. Michelle Arnold. Thank you for inviting me to this conference. Good that we're back again. So just let me figure out this thing. It's backwards. So I always enjoy reading over all the yak literature. I've got a whole folder of it right here. It's always intriguing to me how they evolved, how they adapted to their surroundings. Here's an animal that for thousands of years has been on the Shanghai Tibetan plateau, where it's cold, really cold in the winter, low oxygen conditions. These animals are rarely ever given any supplementation at all. So they didn't have any extra feed during the winter, during that harsh winter. They never got extra mineral, and yet they have survived. All those adaptations certainly we're just beginning to understand. I was really excited this year to finally see some articles come out in like 2021 on, they're starting to come out from China. We didn't see many publications come out of China until recently. So I did get a couple of new ones. The one that really got me excited was a 2019 mineral nutritional status of yaks grazing on the Shanghai Tibetan plateau, and I thought finally we'll have some good values versus just using cattle. Although cattle are going to be really close. You know, for some time I was unsure if a yak would be, say, in between bovine and sheep or more similar to a goat, but they are almost smack on with cattle. A couple of differences, and I'm not certain that it could be even methodology that we use to measure, so the differences that we see. But nonetheless, so we're starting to get some good information. So back to that old introduction there of they are raised where there was low oxygen, where it was cold, so we bring them here to the United States, and especially to Kentucky, where it's not. We've got plenty of oxygen, and but definitely warm temperatures. So one of the things we do see that's problematic is when they're trying to stay cool, they're often stay too damp. You know, their skin gets moist, and you start to see some of these skin diseases, which often we think are fungal, but actually are. And looking back over the records at UK were bacterial, dermatophilosis. So be thinking about that if you see like scabby skin, where the tufts of hair pull out. Those are usually bacterial, not fungal. So you need to treat them. The best thing to do would have a vet come out and take a sample of the skin and submit it, so that we can actually do some diagnostics on it, make sure it's not fungal. But oftentimes those are bacterial and need some antibiotic treatment. So I won't go into nutrition a lot, because thankfully Dr. Lempuler is here and he's going to tell you much more about this, but we see the same problems in cattle, in that nutrition is especially in lactating animals, is really overlooked a lot of times. Good nutrition is essential to have that healthy calf. Cows need adequate energy, so we focus a lot on protein. You know, if you talk to somebody about their hay, they can tell you to the decimal point what protein percent is in their hay, but very few can tell you about the energy, and they're equally important. So a lot of times our hay produced is great in terms of, or at least good enough in terms of protein, but really poor in terms of energy. So if they don't have that energy, they're going to lose weight. And in late pregnancy, early lactation, that's a problem. That's when we start to see problems with the calf that's developing, and also when they're lactating. So you don't want to skimp on it. Cows that lose weight in the last 30 days of pregnancy are at high risk for weak or stillborn calves. Remember, they're going to be slow when they calve. If they don't have much energy, Poor quality and quantity of colostrum, which we'll cover here in a minute. Calf is slow to stand up and nurse because of that delayed calving. Risk of navel infections because, again, they're down too long, not up and nursing right away. And then later on, the cow will be slow to rebreed. So calf colostrum absorption, really important. Best in the first 6 hours of life, steadily declines to 0 in 24 hours. So this passive transfer, remember that calves are not born with immune systems, with functional immune systems. They get their immunity that's protective from colostrum, that first milk. And what the antibodies in there are called IgG, the immunoglobulin G. And during that first 24 hours, especially in that first 6 to 12, is where most of the absorption goes from the gut into the bloodstream. And the older they are, the less transfer there is. That's called passive transfer. So if you don't get them nursing, or they don't have that colostrum early on, then they're not going to be protected. And this protection will last depending on what we're talking about, bacterial or viral. But typically we say 2 to 3 months, maybe sometimes up 4 to 5 on some of the bugs. So it is very protective, very important, especially in that neonatal period. So here was a study done in 2016. This was another one that a recent change in the composition of yak colostrum during the first week of lactation. So now we're looking at the cow. Now we're looking at her colostrum production. And in this study, they collected it at 1 hour postpartum, so 1 hour after calving, at the highest concentration of protein, solids, ash, vitamin A and E, beta carotene, and most of the minerals. These components decrease rapidly within 24 hours. But look at this IgG at 24 hours postpartum. The IgG, remember that's the antibody content, decreased from 87.78 milligrams per milliliter. That was what it was at 1 hour, down to 6.58. 7.5% of the value in 24 hours. That's huge. So if you wait a day to collect your colostrum, you basically lost it. It's not just that the calf can't absorb it; the antibodies aren't even there. It's real important to get on there fast. The highest concentrations of all minerals were found at 1 hour postpartum. So here was their graph from that. Change in IgG over time. So time hours is on the x-axis. IgG concentration. That's a steep curve. That's probably steeper than what we see in cattle, I think. So that was their conclusion to that. In summary, concentrations of nutrients in yak colostrum changed dramatically within 24 hours. As for IgG, the first 2 hours after calving were the best time to obtain the highest content from yak colostrum. The current results in known neonatal bovine biology suggest that yak colostrum should be provided as soon as possible to help them obtain adequate nutrients and immune capacity. Yes, ma'am.
Could you comment on some of that colostrum we have from the farm stores and what that does? Because sometimes the moms don't make it.
Right, yeah, exactly. Sometimes they don't. So there are colostrum replacements available, and you have to be careful when you buy these because there are colostrum replacements and there are colostrum supplements. 2 different products. The supplements do not have nearly as much of that antibody. But the ones that are replacements and they're milk derived, I like those the best. They do a great job. I mean, if you get them mixed into the calf early, you're going to get a good, an adequate amount of antibodies. The trick is the fact it didn't come from that animal's mom, so you don't get the specific bugs for that farm. I mean, it protects them, but if you've got a problem that's right on that farm, maybe not so good protection, as good. So it's best to have it from, if you can collect from another animal, maybe one that loses a calf, go ahead and milk her out and save it, freeze it. If you freeze it, make sure you thaw it slowly. Don't stick it in the microwave. Don't microwave it. You gotta thaw it out slowly, or it teenagers those proteins. Did I answer your question?
Yes.
We bank colostrum here for calves. It's good for a couple of years in freezing.
Right.
Yeah.
But you do have to be careful if you say go to a dairy that's nearby and maybe get some dairy colostrum. There are some diseases that can be passed in colostrum. Meionis disease being maybe the one that comes to mind. So be careful. If you're getting it, it's best to pasteurize it. If you can pasteurize that colostrum before you deliver it. Okay, so again, not skimping on energy, and I know Dr. Limkuhler is going to cover this, but I don't think we can cover it enough. Just to note that milk, that's the red up here. This milk energy that they need for lactation is big. When you think about the blue, this blue is just maintenance. That just keeps them alive. And then milk is a huge energy drain. Pregnancy takes some, but not nearly what lactation does. So think about once you wean that calf, this is your opportunity. Right in here, put some weight on her if she's gotten very thin. So body condition scoring is a way to assess, how much fat they're carrying, basically. How much fat is on their body. But in cattle, we do it from 1 to 9. Beef cattle, well, 1 is thin, 9 is obese. So hard to do in yaks. Why? You can't see them. You can't see the things we normally look for. You can't see the bones. You can't see when they're. You can't see ribs very well. You can't see anything. You've got to go in and feel them. You've got to actually go in and feel for bones in order to get some idea. And we don't have a good scoring system for yaks. Every type of animal is going to be a little bit different in terms of where they deposit fat. And this is just one of these illustrations about different species put at different places. So you're going to have to use your hands. You're going to have to use hands to know if you're getting thin. So in general, reproductive rate is low. Under normal, like in China, they probably only have a calf every 2 years, and that's simply because they're not able to supplement them very well. But that is not inherent in the yak, it's inherent in their nutrition. So trace minerals, we're going to talk about those kind of at length here because we've looked at this over several years, and I'll give Greg credit. He has really done a lot in terms of getting us some ideas about serum levels of trace elements. Over the last several years, we've had about 55 samples submitted from well animals, well yaks, and run serum trace elements on there. So this is a liver panel, but I'm talking about blood, serum. And we've finally been able to develop some good idea about what we're seeing, and then I got this paper from 2019, so I'm beginning to feel comfortable in saying what we're deficient in and what we look pretty good on. So the immune system really depends on trace minerals, especially copper and selenium, in order to fight diseases. And in Kentucky, we tend to see copper and selenium are the two that are very deficient in cattle. So this is from a liver. This is a liver sample that was at the lab. You can see the selenium didn't even show up on our scale. Copper was at 6.4 on a scale of 25 to 100. So liver is the best is the best thing we have to assess trace minerals. What's the problem with that? The problem is they either got to be dead or we've got to take a biopsy. So biopsies are somewhat invasive and there is some risk involved. So most of these that we run on the liver are ones that have died. We don't get very many submitted that have gone to slaughter. I think that would be great because if we had liver from slaughter animals, then we know they were healthy. You know, most of these are at the lab have died from some kind of disease process. So selenium, very important in reproduction. Abortions, more common. Don't make good colostrum. This is a big one. Delayed conception, retained placentas. A selenium deficiency can affect the heart muscle, especially in calves. Poor immunity to infectious disease. You see this over and over and over. Decreased vaccination efficacy, meaning you give them the vaccine and it doesn't work. It doesn't do what it's supposed to. Copper deficiencies, this is where we'll probably hammer it home because this is what I see in the yak data. Is copper deficiency over and over and over again. So it's important for growth, copper, important for growth, immune function, nervous system. It's a component of a lot of enzymes. It can produce significant damage to heart muscle if you have a deficiency due to reduction of this of the copper zinc superoxide dismutase activity, which is really a fancy way of saying there's some oxidative stress that copper is important. Deficiencies can be what we call primary or secondary. Primary would just be not getting enough copper. Secondary would be there's too much molybdenum or sulfur in the diet that complex with the copper, so it can't be used. There is one publication from the northern Shanghai Tibetan plateau where they had this disease called shakeback disease, which they have attributed to low copper. It was a secondary deficiency due to high molybdenum in the soil. And symptoms with that were they were eating the soil, pica, and they eat the soil, emaciation, so they're thin, an unsteady gait, when they kind of walk and they shiver and sort of tremble, but it did not affect their coat color. They treated these animals with copper sulfate and they recovered. So they felt they were pretty confident that this was a secondary copper deficiency. They had very high molybdenum in the soil in this case. Here's another study. This was a production performance, and I want to talk a little bit about the selenium and vitamin E. So this study was done on the effect of selenium and vitamin E on reproductive things. So we're looking at birth weight of calves, mortality of calves at the first month, growth rate of calves, survival and weaning, total milk yield, and lactation length. So we got treatment one. This group was the control group. They didn't do anything to them. This group got 5 cc's of, they got 250 milligrams vitamin E, 7.5 milligrams of selenium. Just for reference, for those of you who use multi-bin, 2 mils of multi-bin has 10 milligrams of selenium. So this treatment 1 had 7.5, or treatment 2, I'm sorry. Treatment 3 had 15. So if you're using multi-bin, we're given 2 cc's, that's about 10 milligrams of selenium. If you're using MUC or BOC, well, MUC is 100 milligrams vitamin E, 10 milligrams of selenium in 1 cc dose. So just for comparison's sake. So what they did when they did the study, this was again 7.5 milligrams of selenium, this was 15, double. Look at the difference there. Birth weight of calves, not a whole lot of difference in birth weight there. Look at the mortality the first month. 1 of 7, they didn't lose any here. Growth rate was pretty similar. Survival to weaning, a little bit better here. Total milk yield, that's a biggie. 267 versus 484. And lactation length, 245 versus 357. It's really, really helped these females. And then in the second, this was actually another one they published, but same study, looking at the effect on the females. And this one, this is your control group here. This is your 7.5 milligrams of selenium, that's the 15. Placental expulsion, so they cleaned up. They got rid of the placenta. Look how much shorter, 3.8 hours versus 6. Big difference there. Having abnormalities, 0 versus 28.6%. Uterine involution, much faster. Having the first estrus, 110 days versus 162. It's a big, big influence here of selenium on reproduction in this study. Days open, 140 versus 185. Services per conception was 2.1 versus 3.2. So definitely look at supplementation with selenium, vitamin E. You got to talk to your vet about it. You know, don't go hog wild. Selenium is not a safe compound to give lots and lots of it. It's got a very small safety margin. So you don't overdo it. You use the label directions, especially like multi-min. You know, you're not going to do what they did here. They gave this twice, 1 week apart, 30 to 40 days before calving. If you're going to do that, work with your vet, because you do need to be really careful when you're administering these products. So very little information. Thank goodness we've got more information than we used to. You'll probably ignore a lot of this because I'm still in the process of trying to figure out how cattle and yaks are different. I know they're very similar in a lot of ways. Our selenium levels, our range in cattle is higher than what they're giving me from these publications. And again, that may be just a difference in the way they measure it. Copper, they do say for serum at 0.6 parts per million, that's going to be the bottom. You don't want to go any below that. Of these 55 samples I had these were well yaks, out of the 53, 43 of them were below that. And this is a good management. Under good management, 10 of those were extremely low. You put on the extremely low level of copper, where they were probably having clinical signs from that. So one thing to get out of this is don't buy these minerals that are all-purpose minerals for all species. Have you all seen those? They're everywhere. Feed it to anything. They got a cow in front, a horse, sheep, goats. You know why you don't want this? There's absolutely 0 copper in them. They take the copper out because copper can be toxic in sheep. So they are very, very careful to not put any copper in these, or if there is any, it's a very, very small amount. So be careful. Be careful. Get good at reading labels, or if you don't want to do that, send them to us. Let us read the labels, because you need to know. You need to know what you're feeding. The other thing we've run into with yaks is they don't much like free choice mineral. They don't like to eat it. You put it out there. You think about the way that they adapted over the years. They got most of their mineral from the soil. They licked it up. They got a lot of their trace minerals from plants, but they got it from a variety of plants. It's not just grass. They got it from everything. I mean, I was reading one of those articles about the diversity of forages and all the different minerals depending on what forage it was. We don't have that. We don't offer them that diversity. So we really need to provide it. So I think with yaks, you probably got to be creative, in how you get that mineral in there. Find a feed that they like and have the mineral mixed in. That works pretty well. Mix it in there at the level they're supposed to get every day, so they're getting it. They had boluses at one time, called those reloader boluses that I thought were going to be great for yaks, but they took them off the market. They're kind of a slow release copper bolus. But it's hard. It's hard to rely on pills and shots. You really need to do this orally to keep that level steady. So I know that they are fussy about trace mineral. So you do need to think about how you're going to deliver that. And consumption's weird. I mean, you can put out minerals some days and it sits there, and other days you put it out and they'll eat it as fast as they can. So that's typical with cattle too. This Vijay Paul is a researcher over in India. He sent me this. They make an area-specific mineral formulation, which could be done here as well. They found out, this was in India with high rainfall, and they found those 4 minerals were below the critical level, and then they made this specific formulation. And they put it in feed blocks. They made it in feed blocks with locally available feed resources, and that way they could transport it. So it's done. I mean, it's done in other countries in order to help with this trace mineral. So the blood trace mineral analysis we do at the lab, and it's not too expensive. It's $35 per sample. If you send in 5 samples or more, then it goes down to $30 per head. We use this ICP-MS technology. It's good. And again, the problem is when we look at these studies, not everybody uses the same. Not everybody uses the same machines to measure. So that makes interpretation kind of iffy, because you don't know what the difference is between one machine to the next. And often these things don't give any kind of reference range. So we're kind of stuck. We're kind of stuck dealing with what we have. We can't communicate with these guys. Most of the time, if you try to send an email to China, it gets interrupted. So I'm coming out of UK. So I can get them over to India, okay, but I can't, there's limits on how much we can do in terms of communicating with a part of the world that has dealt with yaks forever. So we do have limitations as far as interpretation on these trace minerals. I got a graph. It's not the best picture in the world, but think about copper and selenium especially. They are stored in the liver. That's a storage organ. So what the body's going to do is keep pumping it out of the liver to try to keep that level high. They're going to try to meet the needs of that animal. They're going to keep pushing it out to the bloodstream that depletes what's in the liver. That's why the liver gives us a much, much better picture of what's going on. But so they go, once they push it all out, then you start getting down here to where you've got clinical signs of disease, because they've really depleted their store. So the problem with sample of blood, if we take blood, let's say at this point in time, we're still going to look pretty good. We're still going to look pretty good on our serum count, but really in the liver, it's a different story. So when we start seeing deficiencies in the blood, we're getting down here. We're down here because our liver's already depleted. So we need to be thinking about that when we're seeing 45 out of 55 samples low in copper. We're already depleted of our liver copper. We need to pay attention. Pay attention to that. And again, it's not something you'd want to just blindly go out and give them injections or boluses. Copper comes in boluses. You wouldn't want to just give CopaSure boluses, every now and then and say, well, this ought to take care of it. You need to do this carefully. Copper can be toxic as well. So it's where you got to work with your vet, maybe do some of these trace mineral analyses so you got an idea of where you stand. Some of these samples that came from like Colorado, they were extremely deficient in copper. And others, using like multi-men, they were staying right on where they should be. So everybody's situation is different. That's what I wanted to tell you. This copper looks like it's the one that we need to focus on, but be cognizant that there are differences in soil, differences in forage uptake of copper. So, and that depends on where you are, where your farm's located. So, challenges, adequate intake, energy, protein, and trace minerals. Dr. Lynn Kuehler is going to address your energy and protein. Knowing your nutrient quality forages, testing, and I'm sure he'll cover that as well. How do you correctly assess body condition with that long, fluffy hair? And like Greg said, you got to really watch these animals. You think about the way they were, the way they adapted. They are really stoic. They don't show a lot. They're not going to show you when they're sick. They are going to hide it as best they can, and I'm not really sure they're hiding it from you. It may be just they're such stoic animals. They just don't show a lot of pain, and they don't show a lot of disease problems. So you gotta know what their normal is in order to recognize the abnormal. Any questions?